We humans are visual creatures. We rely heavily on images to gather information about our surroundings. If there is little light, sometimes we can also rely on other senses, such as hearing, to understand what's going on in our environment. Let's do the test. Close your eyes and listen to the following sound. Do you know where this sound comes from? Exactly, we are in the jungle. And this one? Yes, indeed, it's a restaurant. So the sound gives you information about a certain location and allows us to recognize certain places and events. Underwater though, visibility can be very low because light is strongly scattered and absorbed. Moreover, sound propagates faster and better underwater than in air. And that's why most of the marine animals, they don't use visual cues to interact with each other or to gather information about their surroundings, but they use sound to do it. Not only animals make sound underwater, but also wind, rain, waves, geological events, amongst others. In addition, we humans have introduced sources of artificial noise in the ocean and seas. For instance, shipping, construction works at sea, or operating windmills. The sum of all the sound sources present in a certain environment is called the soundscape or the acoustic habitat. A soundscape then can give way more information than an image, especially in environments so turbid as the Belgian part of the North Sea, where visibility is practically non-existent. That's why underwater acoustics has become such a hot topic on the past decades. In my research, I study soundscapes to be able to monitor the health status of a certain ecosystem. What I want to answer are two questions. The first one, I want to be able to characterize a certain soundscape, so I want to know how a certain habitat sounds. Let's think back about the restaurant we heard before. When we hear the tables, the glasses clinking, the cutlery, we know we're at a restaurant, but we don't know the waiter name or what the customers are eating. The second question is, which relevant biological information can I actually extract from this soundscape? Thinking back again to the restaurant example, if we hear a lot of noise, I can think there are lots of customers, and this can mean that the business is doing very well. On the other hand, if it's very quiet, I can think maybe they're on holidays or maybe the business is not working very well. And in this way, I can monitor the health status of this ecosystem, and I can do exactly the same for marine habitat. To analyze these soundscapes, I need to acquire underwater sound at different locations in space and time in the Belgian part of the North Sea with specialized underwater microphones that are called hydrophones. At VLIZ, we even use marine robots to be able to collect this underwater sound. Once the data is collected, I try to classify these different habitats only by how they sound. A very common approach that has been used for the past decades is to detect the biological, physical, anthropogenic events that take place at a certain location using artificial intelligence. But to do so and detect these events, it is necessary to have previous knowledge about how these sound sources sound. And this is something that is very time-consuming and very hard to acquire in the Belgian part of the North Sea because there is no visibility. Therefore, what I try to do is I try to characterize the entire soundscape rather than specific events. By doing so, at the end of my PhD, I hope I'm able to distinguish two different habitats only by how they sound. For instance, I will be able to distinguish a windmill farm from a nature reserve only by their soundscapes. This will then allow to monitor the health status of these environments only by listening to the acoustic habitat.